Hi everyone, welcome back and to the second part of our Omron CP1H data shifting instructions. And we're going to pick up exactly where we left off, and we're going to talk about the rotate. And now the rotate, what it will do is move bits all the way to the left here, one by one, until it reaches to the end bit. It will then set the carry. The carry then can be used, if you wanted to move in and set the beginning bit again. So what we'll do is enable that bit, and what we'll do is we'll set something on our output channel here, which is H8. Set that to the value 1, and you can see here it rotates all the way through, and when it gets to the end it will set our carry. All right. So rotate is just another shift register instruction with a slightly different, because we're talking about the carry flags within the controller now. If we look at the double one, again we're going to be using two words. So here's my double rotate left. So we'll energize it, set it on, let it go, our pulse flag here. Notice we still have our differentiate up on our rotate left, or double rotate left. Which means that it only activates on the transition from off to on. So here we have 9, so it's 9 and 10 that we're actually manipulating. And we'll just pull that out here, and we'll change that to, again, we can change different values. We'll put a value of 7 in there. That'll be hex 7. And when we do, it turns on the 3 bits, and you can see the 3 bits then shifting through, and when they go to the end, they'll keep on the first register. It goes to the second register here, and it will continue shifting until it goes out to the end. So at any time during the shifting, we can also use those bits in our program to fire things off. And again, like we said last time, it's like looking at a conveyor belt. You can see the tracking of information within the on the belt itself. And our sensor would actually fire off or energize those bits. So the next one, we have a rotate right. There's my double. Rotate right is basically now taking it from bit 15. It shifts it to the right down to bit 0. What we'll do is we'll energize it, turn it on. So our 1 second internal clock bit starts pulsing, and now we're dealing with H11. So we'll energize it, or we'll put a value of it, and we'll put in the value of 8,000 hex, so that we can see that bit shifting down through. And then we have our double shifting right, or our long shift right, and we'll enable it. And that one will actually use the 2 channels starting at H12, holding register 12, and it goes to 13. So what we'll do is actually turn on the upper bit of H13, and we can actually watch that then rotate to the right, which is exactly what it's doing. When it gets to bit 0 of that second word, it'll then activate the bit 15 of the first word until it's lost at bit 0 of the first word. There we are right there. Now our next one is actually rotate left without carry. Now you almost would think that this would be the same, but quite it isn't actually. And what's going to happen is that we're going to rotate to left, and the bit 15, if it's on, it's not going to set the carry, but it will energize bit 0 again. So we get a true rotation of the actual red output register. So any bits that are located within that register just get rotated around it around. So let's see that in operation. We'll turn that on to start our 1 second clock bit flag, and it's on 14. So we'll look up HR14 here. We will set this to a value of 1. deal with the 1 bit here, and you can see here that as that bit goes through, when it gets to bit 15 here, it should then energize bit 0 again and keeps rotating around. So rotate left without carry is a true rotate within that register, if you think it like that, like a big carousel. We just keep on going around and around. And that'll go on infinite unless I clear that or put a 0, write a 0 into that register, or I could actually add or put another value on, and I have multiple bits. Let's look at the next one, which is double rotate left without carry. Again, all we're going to do now is deal with 2 registers starting at 15. So we have 15 and 16. So what we'll do is, before we actually energize it, let's put a couple of values in here. We'll put the number 7. So it turns on the first 3 bits here, and we'll put the value of, say, 1 here, and it's turning on the first bit here. Now with this rotate, basically everything's going to go back up. It's going to shift again to the right, and keep going. So let's energize that and take a look. There we go. So here we are. We're shifting through the bits here. We have the 1 and we have the 3, and you'll notice that again we're just rotating. So as it leaves this, it fills in here. As it leaves the other one, it fills in the opposite. So again, we're just cycling through and rotating this information. Now we have a rotate right without carry. So there's my double rotate right, double rotate right. So rotating right, basically what we'll do is we're going to right rotate instead of the left. So let's energize it. And at the same time, let's turn on the double as well. So we're talking 17 and 18 and 19 now. So there's my 17. We'll bring this up here, and we'll put a value of 3 in there. And you see immediately rotate it back to the beginning again and kept going. So there it is, keeps on rotating around. And my double rotate, let's put a value of 3 in there, or let's go 7. So now with a double rotate, you can see here we're rotating now at 18 and 19. So once it's gone past here, it'll then pick up here. So again, rotation. The next instruction, alright, so far what we've been doing is dealing with bits at a time, just single bits. Now what we're going to do is look at shifting digits. So these are 4 bits at a time that's going to be shifted. And the first one we have is 1 digit shift left, and we're going to go starting a word D20 and data memory 20 and data memory 21. So if we have here, there we go, and what we're going to do is we have actually 2 instructions up here. We have 1 digit shift left, and we have 1 digit shift right. So what we'll do is they're both on the same information. So first of all, let's put a value in here. We're going to turn on those 4 bits. So we have our 4 bits here. So the digit is actually 4 bits long. It will then shift those FF into this one, this one, this one, and then continue left until it gets to the end. Or we can energize this one, which then starts shifting it right. So let's set that on. So here's my shifting left. Right, and it will set off. So I've got to this part here. Now if I shift right, it goes backwards. Right? So now what we're talking about is shifting multiple bits on at a time. our next instruction is shift N bits left, and this one is kind of unique because what it will do is allow you to specify the beginning bit and the shift data length, and it shifts the bits themselves within the instruction. So here I have H20, which is right here, and what I've done is to illustrate this, we've filled it up with all F's. So I'm going to take the beginning bit, which is going to be number 4, and our length of 3, and what it will do is it will shift a 0 into, or shift a 0 in, and you can see just those bits within that word are going to shift. So let's energize that. And what you see is, again, just like it said here, bit number 4, which is this one, the starting word, it was shifted in with a 0. So let's turn that off. And then we turn that on again. And again, get the next shift over. Now remember, we're only going to go 3. Off, and then turn it back on. Alright, so there's my third one. So now when I turn this off, nothing happens because there's our 3 shifts, bits that we're shifting within that register. And then the same thing applies. We do have a shift N bits right. So within that register, we're shifting the bits again. This is on channel 20, HR21. So what we'll do is, again, we start with the 4th bit. We're going to do 3. So right here, we should be shifting in a 0, and then this way we're going to go backwards actually. So let's set that on, and sure enough, there's my bit that gets shifted in. We'll turn that off, turn it back on. There's my next one gets shifted in. So again, we're doing the same bit pattern, but we're doing the opposite. We're rotating right instead of left. Turn it off. And one last time. And what you'll notice is then there's my 3 bits I'm shifting. The next one is my shift N bits left. And this goes by a control word, and the control word tells me how many bits to actually shift itself. So if we look at HR22, so in all of our other examples, we always shifted once in. Now we're actually shifting a number of times. We're going to shift 2 over. So if I energize this, you notice that I shifted 0 into the first 2 registers. So I'm shifting, and then what was previously there gets shifted over twice. So I can specify here in my control word the number of shifts that actually get shifted over. And so basically, instead of the 1 shift each time we had that pulse, like a conveyor, we now have 2. We can do the same thing with a double shift. So again, anything we specify in the double, right now we're going to shift 4 over. So it's almost the same as our digit shift left. So let's set that on. And what you see is the first 4 bits here go to 0 because we're shifting 0 into them. They rotate over, and they rotate through the 2 channels because it's a double, and the last one then gets lifted out. So if I turn that off again, and then we energize it once again, it shifts again 4 over. We have just the opposite of these instructions, which is a shift right. So we're going to do shift right on H25, which is right here. And what we're going to do is we're going to shift 2 bits. So basically we're going to shift the right, so the ones in the end are going to get lost. Okay. So this is exactly what our picture says up here. So let's do that. Let's shift that on. And sure enough, there's my 2 bits that got shifted in. And then the one here on the right, it gets lost. Now our next one is the long shift. So this is a double long shift and bits right. So it's the exact same as the previous one, except for now we're using HR 26 and 27, which will then shift this data in. So as I energize this, it should actually shift this in at the most significant bit here. And our control word is 4, and then it will actually move everything else out. The lower or least significant 4 bits of this word then gets shifted out, so I lose that information. So here I'll turn that on, and sure enough, that's exactly what happens. Alright, so shifting within the controller or the PLC is quite straightforward. You'll see that there's quite a few different manipulations of the same information that you can do. So each with a slight variance. Now if you like this video and like to see more, there are 3 ways in which you can help us out. You can give us a thumbs up so other people can find this information just like you have. You can subscribe to our YouTube channel at the end of the video, or you can go to accautomation.ca, subscribe to our website. When you do, you'll get notification every time we publish new content to the site. You'll also get 2 free ebooks on numbering systems and robust data logging. And the third thing to do to help us out is tell a friend or colleague. Alright, that's it for today. Thanks for watching.